Povremeno se na raznim poljima pojavljuju ideje koje su toliko drugačije od opće prihvaćenih da nailaze na dvojake reakcije. Nekritičko prihvaćanje ili pak jednako strastveno odbacivanje. Htjele to te ideje i njihovi nositelji ili ne, ali usporedba s rukavicom bačenom u ring nameće se sama po sebi. Na polju fizike u posljednjih nekoliko godina neke takve radikalne ideje iznio je švicarski fizičar Nassim Haramein, osnivač Havajskog instituta za sjedinjenu fiziku i projekt rezonancije. Dok na nekim krajevima dobiva priznanje, na drugim krajevima njegove se ideje osporavaju. Ono što se ne može osporiti jest njihova intrigantnost. Kako drugačije i preciznije opisati koncept da svu materiju, od subatomskih do galaktičkih i svemirskih razina, čine crne rupe raznih veličina? Da živimo u fraktalnom svemiru kojeg se može i matematički opisati, a glavna odlika tog fraktalnog svemira jest rezonancija, to jest povezanost svega sa svime. Ako se čini da ove ideje vode prema metafizičkim zaključcima, dojam je ispravan. Kao takve, sasvim je jasno da će se prvo pojaviti ovdje, na rubu znanosti. Gospodine Haramein, dobar dan. Kako ste se našli u Hrvatskoj?
I was invited by Bianca Charles to come and give some talks on this amazing cruise through the beauty of Croatia. Bridging Heaven and Earth Foundation got me over here, and I'm so delighted to be in Croatia.
Ponudili ste radikalno drugačiju, novu ili možda vrlo staru sliku svemira, jedan fizikalni model. Pa prije nego što saznamo kako on izgleda, možete li objasniti ono što smatrate glavnim problemima u suvremenim fizikalnim modelima?
Well, there's many issues in today's physical models that have to do with the way we write mathematics and the way that we understand dimensions. We have a tendency to create models, mathematical models, and then extrapolate them to physics, thinking that because we created a mathematical model that adds up, that automatically this must be the way the physics works, and that's not necessarily correct. For instance, we make hypothetical models of mathematics that are based, for instance, on Cartesian planes and dimensions, assuming that there is one-dimensional, zero-dimension, one-dimensional objects, two-dimensional objects, and three-dimensional objects, and then we extrapolate this in conceptual physics, and we come to a conclusion about the physics of our world that don't necessarily apply. For instance, there's no such thing as a two-dimensional surface. No surface has no thickness. That's a conceptual idea in a man's head. That doesn't mean that the universe makes two-dimensional surfaces. So when we write physics based on this, we get maybe a little bit the wrong impression about how things work, gravity and forces and the relationship of information in the universe. And we end up with maybe the little bit of the wrong picture. And then when we rectify that, then we can get all new views that can bring us further. So it's really important, you know, to be able to actually look at our models at the very deep levels and make sure that they match reality in such a way that it will give us the right physics.
Objasnite nam ideju da je prostor temelj svih stvari i da povezuje sve.
The thing that's being discovered right now, not just by me, by others, is that space is not, you know, we know space is not empty. There's electromagnetic wave between you and me. There's all sorts of stuff. But we're finding that space at the very fundamental level, very close to the, you know, very fine level of the Planck scale, is actually very energetic, that it's full of information, and that it may be a metric that actually connects all things together, so that things are appearing separate and independent, but underlying this independence is a connected network that connects them all, so that information is shared across all systems. So this is becoming apparent in the physics I wrote, which predicts very, very clearly and specifically and accurately some of the fundamental things about the universe, like the mass of the electron, you know, the mass of the proton, the strong force, gravitational fields, and all this. So it actually, you know, gives a different picture. And this picture is now starting to emerge as well in other models of physics. In the standard model, they are kind of converging to realizing that maybe it's space that creates matter, not matter that defines the space.
Kako ste došli na ideju da je zapravo atom više nalik crnoj rupi? Potvrđuje li matematika taj model? Na koji način? Jeste li ga objavili u znanstvenim časopisima?
Well, you know, I started to realize that when you look at the very fine structure of space-time, you can start to describe black holes in the universe using the energy in the vacuum itself, and it started to emerge in the model. This is some 20 years ago, that maybe when we look at the galaxy with a black hole in the middle, we're actually not looking at the galaxy making a black hole, but a black hole making a galaxy. That space-time, like this very fine structure of space, is actually spinning into existence a black hole, right? That the black hole is the spin of the structure of space itself, and what we see as a galaxy is actually the stuff that got caught in the spin. A little bit like when you have coffee, black coffee in the morning, and you spin it, it doesn't appear like it's spinning. If you take the spoon out, you can't tell it's spinning until you put the milk in it, and then you see like a galaxy appear, right? And I start to write physics based on that the space is what's actually creating the effect, not the matter in it. And then I applied that at all the scales, a star and then planets and solar systems, and then eventually to the atom. And I realized that the atom with the nuclei in the middle could be described in the same way, where it's actually the Planck field of information that's spinning in that region of space, like a little vortex. And what we see, because when we look in an atom, we don't see little billiard balls, right? The particles are not little billiard balls. The particles are little charge that we see, like there's a boundary, a little charge boundary. That's why the radius of the proton is called the charge radius of the proton, right? And so basically that, you know, this is the same phenomenon, so that the center of the atom, the nuclei of an atom, must be a little black hole. And so then I calculated, if that was true, how much gravity two little black holes orbiting in the middle of an atom would have, and that added up exactly, not approximately, exactly to the force we measure when we look at the force that's holding the protons inside the nuclei of an atom. So then that confirmed that this must be the case. But then I had to explain in more detail how these mini black holes come to exist, and I eventually was able to use a holographic solution that shows that basically the information in terms of these little Planck oscillators in the vacuum are inside the proton, and the information that comes out is the mass that we measure for the proton. We measure only a very small percentage of what is actually there in terms of energy.
Kao što ste rekli u jednom predavanju, niste htjeli ignorirati gustoću samog prostora. Pa onda, kada pričamo o brojkama, koliko je zapravo gust taj prostor?
It's extremely dense. The structure of the vacuum at the quantum level is very much energetic, extremely energetic. You know, Einstein noticed it, Wheeler noticed it, many others, and you know, the numbers are extremely large. So for instance, because the little oscillators are Planck size. So the Planck size comes from the Planck constant. It's a little energy, packet of energy. Einstein called it a photon of energy, right? And these little packets of energy at the Planck scale are teeny, very, very, very small. So that if I grew one of the little Planck-sized packet so that it would be a grain of sand, then all of a sudden the proton would be from here to Alpha Centauri, which is about 40 trillion kilometers. So you can imagine it's very small. So if you calculate how many of these little packets of fluctuations of the vacuum, electromagnetic fluctuations, are inside the structure of space-time, in a centimeter cube of space, you get 10 to the 93 grams per centimeter cubes of this Planck energy. It's huge because the density of the universe, like if you take all the stars in the universe and you squish them into a centimeter cube, you would have 10 to the 55 grams per centimeter cube. You still would be missing 39 zeros, you know, to get to the density of the vacuum, how dense the vacuum is, and in a centimeter cube. So now if you calculate how many of these Planck little electromagnetic oscillators are inside of the volume of a proton, which is extremely small. The volume of a proton is 10 to the minus 39 centimeter cube. It's very teeny. There's still 10 to the 60th little Plancks in there. You multiply it by the Planck mass, which is 10 minus 5, the energy of one Planck, to get the energy of all the Planck inside the volume of a proton, and you get the exact mass of the universe. You get 10 to the 55 grams. So what I'm saying is that the universe is holographic, and all the information of all the other protons are present in one proton in terms of information. Not all the things in the universe are in one proton, but the information is in there. Just like, you know, the holographic plate, if you cut it in pieces, you still get all the information of the original plate in each one of the pieces. This is what a hologram is. You can think of it as like the information of an orchestra can be put on a CD, right? Just in terms of information in the magnetic field of a CD, right? Or an optical, you know, disc. And so the same thing you can say about a proton, like that the proton is connected through little Planck wormholes to all the rest of the universe, through all the other protons. And this is what makes the fabric of space, and it's all talking so that everything knows what everything else is doing. And that's how the universe actually self-organizes. It's a very different view. It might sound really radical, but I assure you, I'm not the only physicist that's coming to these conclusions at this time. Some very prominent physicists are coming to similar conclusion that entanglement between particles, which is a remarkable thing, that particles, no matter how far they can be, if they're entangled, you can change this one and this one change instantaneously, is because they're connected through these little wormholes that connects things in space and makes up the fabric of space-time.
U vašem modelu, koliko sam uspio shvatiti iz vaših predavanja, proton je na neki način mnogo veći ili barem mnogo drugačiji od protona u današnjem modelu. Na koji način se on zapravo razlikuje od onog prikaza ideje o njemu kakav je prisutan u današnjim modelima fizike?
So the model of the proton in my papers, in my work, is not bigger, is the same size. It has a different mass. But it doesn't have a different mass than the mass we measure, okay? You have to read all my papers, not just some of the papers, right? So when you read all my paper, initially I showed that if the proton was a black hole, and then it would have a much larger mass than we measure, right? Then the gravitational force between those two black holes would be exactly what we measure in the nuclei of an atom, right? My point is that in the standard model, although the mass of the proton is much lighter, they throw in that force freely without accounting for the energy to produce that strong force. And if you account for it, then you get to the mass of the proton I came up with. And then I showed that the reason we're not measuring that higher mass for the proton is because there's a boundary condition on the surface of the proton that's a holographic boundary, so that all the information that's inside the proton is not being measured on the outside, because we're on the outside of the black hole. So we're only getting part of the information, a very small amount of the information. But the information is inside, so the universe is creating a force equivalent that what's inside, not just what's partially being able to be measured on the outside. When I do the math that way, okay, and I come out to like calculate the mass of the proton, it's extremely exact, and then I calculate the radius that the proton should be, then that radius is actually smaller than the radius of the proton that's measured, that is in the standard model, right? And that might be what you meant, is that it's smaller, right? But the new experiments measuring the proton more precisely than ever before comes out to my radius and says that the standard model radius is off by 4%. So this new experiments that are done in Geneva in the accelerators are confirming my model and showing that the standard model is wrong about the structure of the proton. And that has a lot of implication to the standard model. 4% might not sound like much, but if the standard model radius of the proton is off by 4%, it makes all kinds of constants in the standard model wrong. And it creates all sorts of problems and ripple effects. So these new measurements demonstrate clearly that you know, the theory I wrote is extremely precise in describing both the mass and the radius of the proton and the dynamics of the atom. And now I've extended, this is unpublished yet, but I've extended the solution to the electron, so I can show that the solution describes as well the electron and all the electrons in the table of elements, so I can output from the same theory all of the matter we see in the universe.
Nedavno ste dobili i određenu nagradu, jedan vaš znanstveni rad je zapravo dobio nagradu za najbolji rad u fizici. Gdje i kada se to zbilo?
2008, I believe, and it was in a conference in Belgium where I presented a paper, and this was the paper in which I described the proton as a black hole. It was called a Schwarzschild proton paper, and it got the best paper award for that section in the which was the physics section in the conference, and it created a lot of noise and it created a lot of controversy because it described the proton as a black hole that was very jarring to the scientific community at the time. Now it's not so controversial anymore. Other physicists have come to conclusions that subatomic particles are not so different than black holes. They're very similar in the way they act and the way they behave. And so, you know, it has been a long journey. It was, you know, very controversial and created a lot of problems for me to publish other papers afterwards. But I think we've resolved many of these things now, and it can move forward. I'm really excited about some of the latest papers I've published, especially some of the paper I'm publishing about the electron, where I extended the solution to the electron cloud, and I'm able to get the correct mass of the electron with a precision of 99.9999998% accuracy, which is like 1 order of magnitude more precise than the standard model. And not only that, the theory is able to predict all of the electrons for all the atoms in the table of elements. So it actually outputs all the material world we see in our universe very, very, very precisely. It's really remarkable. I'm really encouraged as the theory moves forward that it actually is a model that can unify physics.
Kako je u fizici nastala ideja nečeg što se zove jaka sila i u konačnici kako je u vašem modelu svemira ona na neki način iščeznula, ako je u stvari ikada i postojala?
Well, you know, there is a problem that occurred in physics in which when we realize that protons are charged, right? They're called protons because they have a positive charge. And if you take two positive charge, electrostatic charge, and you try to bring them together, they're gonna repel, just like two, you know, magnets. If you bring the two same poles towards each other, they're gonna repel. And they repel very strongly. It's a strong force. And so when they realized this and they found the protons are squished in a very small packet in the middle of the atom, they had to come up with an idea of what force would force them to stay together, although they would want to explode out. And they thought that gravity was too weak to push the protons together. So they made up this new force. They called it the strong force. They made a model for it. Eventually that led to LQCD, which is lattice QCD. And this model created a lot of issues because, first of all, there's no analytical solution to this model. It doesn't resolve. You can only solve it in terms of modeling in computers, and we've run supercomputers for years and years trying to find an analytical solution, and it doesn't resolve. So that causes some problem. I think there's $1 million prize to try to find a better solution. But as well, they added this force as a free parameter in physics. The strongest force in the universe, it would be much stronger than anything else, and they didn't account for the energy required to produce this force. And so I realized this, and when I accounted for the energy to produce this force, it made the proton little black hole. Not approximately, exactly. You know, it wasn't, if you make the two protons black holes and you calculate their gravitational force, you get the exact force that we measure in laboratory. Now, gravity, one of the objections to this was that, well, gravity drops at the square of the distance, and this is not doing that. Like, the strong force gets weaker very, very fast, right? Exponentially fast as you get further and further from the protons from each other. So there was some difficulty there. But then I showed that that is just because of the mass dilation of protons. So they're spinning around each other very, very close to the speed of light. And that makes their standard mass dilate into the black hole mass. That's why they have such an attraction. But when you push them apart from each other, they slow down. The mass dilation drops as well as the strength of the force. So that makes the force drop at the exponential rate. At the exponential rate that they see. And so it's still gravity, it's just gravity behaves differently very close to the event horizon of a black hole because the velocity is close to the speed of light. So this actually makes it so that there is, no need for the strong force. It can be explained with the gravitational force, and it describes then the structure of an atom in more of a classical way. It unifies gravity with quantum physics. It shows that gravity is the strong force at the quantum level, and so it unifies quantum physics and gravity, which is a big problem in physics. We have physics for big things that has to do with gravity, and physics for small things in quantum physics, and we couldn't figure out how to put gravity into quantum physics, and that's because we had an extra force we called the strong force, and I got rid of that and replaced it with gravity.
Sličan problem koji se pojavio sa tom takozvanom jakom silom, kada se gleda vaš model svemira, pojavio se i sa pitanjima takozvane tamne energije i takozvane tamne tvari koje navodno ispunjavaju svemir, a da je mi ne možemo direktno percipirati. Na koji način i gdje se nalazi paralela?
Well, that's a more complex question, but definitely, from the equations I wrote, then you can start to think about dark energy, which has been described as this Planck vacuum fluctuation at the cosmological level is actually the result of the expansion of a proton to the size of our universe. So if you take one of those little protons that I describe as a mini black hole, and you consider all the little vacuum fluctuation inside that proton, now you take that proton and you expand it to the size of the universe, right? So the density of the vacuum fluctuation at the proton level is 10 to the 55 grams per proton volume. Then you expand it to the size of the universe, you get the exact value of the so-called dark energy in terms of Planck fluctuation at the universal size. So all of a sudden, dark energy is not this mysterious thing that's coming out of nowhere. It's actually the vacuum fluctuation that were present inside the very early universe before it expanded. And then as it expands, the density drops and produce the dark energy that we measure in the universe, that makes the universe expand. And the same thing can be said about dark matter and the amount of dark matter necessary in galaxies, and how the galaxies are not behaving as if there is enough matter in it to make it behave the way it is. So they had to add some 80% more matter in galaxies to make it look the way they look according to our equation. And that's because they didn't consider all the vacuum fluctuation inside the galaxy that are occurring, that are creating the structure of the galaxy. Meaning the galaxy is not, the structure of the galaxy is the vacuum spinning, right? And that is what makes the stars and the dust and all the electromagnetic fields behave the way it behaves, that we see a galaxy. But it's because the underlying structure of space is spinning, and that's not being considered in the calculation. So of course they're missing most of the mass necessary to make the galaxy do what it looks like it's doing.
Kako je vaš model u kojem se protoni imaju beskonačnu gustoću i pritom se rotiraju blisko brzini svjetlosti i smatrate ih crnim rupama, kako je taj model utjecao na ideju fraktalnog svemira?
Okay, that's a good question. So basically, if you look at the structure of this holographic grid, like this information in the field, that makes up the little proton, and the way the proton is connected through the wormholes, right? Basically, you have information going out, and then you have information coming back in. So you have feedback or iteration of information in the structure of space-time. This is very much similar to the way a fractal structure is described in terms of mathematics. You have an equation that gives an answer that you feed back in the equation, get another answer, and you get iteration. You get high level of complexity very, very fast as a result of, iteration of the information. And so, so if you look at one proton and you look at how many little wormholes can connect to one of the protons, it can connect to 10 to the 40th other proton, right? Well, and there's about 10 to the 80th proton. So then each of these 10 to the 40th are connected to another 10 to the 40th. So now you start to see like fractal iteration of the information feedback into the structure of space-time. So you have iteration, fractal iteration of the information. And really, when you look at nature, that's what you see. You see nature is always getting information from its environment and then changing its behavior to evolve and adapt to the environmental condition. So you see information going in and then changing the system so that information is going out, which alter the environment and then coming back in again. And so you look at the structure of a plant, the structure of the leaves of or the branches of a tree, the structure of the roots of a tree, the structure of the human body. You see fractals everywhere. You see this, you know, iteration structure everywhere in nature. And so I think, you know, the fractal, and this is why I called my theory holofractal structure, because it is holographic, but it's reiteration of the information holographically, which gives it fractal dimensions as well.
Rekli ste da je u fraktalnom svemiru sve drugačije nego ono što smo mi naučeni. Znači, u fraktalnom svemiru kretanje je drugačije, u fraktalnom svemiru pružaju se nove mogućnosti crpljenja energije, nove mogućnosti transporta. Koje to mogućnosti svemir kao fraktali, kao fraktalna struktura nama pruža?
Well, there's large amount of different potential application to technology. You know, of course, all of a sudden this view gives a whole new sense of the world. And, you know, every big change that has happened has led to big change in the technology we eventually come out of it. You know, like most of the technology we use today came out of some of the work that was done in quantum mechanics, some of the work that was done in relativity allows, you know, planes to fly and all this stuff. You know, this has huge implications. For instance, it gives us a new understanding of gravity. It gives us a new understanding of energy and where the source of mass comes from. It says that there's this field between you and me, there's this field between atoms, there's this field inside atom that is full of energy potential that can be tapped if we understand how it works. And not only could we tap into it, I mean, even if we extracted 1 billionth of a percent of what's present in 1 centimeter cube of space, of this energy density in space-time, we would be able to, like, power the planet for thousands of years, right? Because the amount of energy present in that space is huge. This is electromagnetic energy. If we can tap into it, and with this theory we start to understand how it works, then not only can we power the planet using vacuum energy, using the energy at the source of matter instead of trying to use matter after it's produced, but as well we could create gravitational field, because now it's telling us that gravitational field is not just space-time curving as Einstein described it, just like the water on the surface of your bath when you pull the plug curves and your rubber ducky starts to orbit, right? But actually the curve is occurring because all the water particles in your bath are spinning, right? This is showing us that the little Planck field is spinning, making like little vortices. We call them galaxies, we call them stars, we call them atoms, subatomic particles. And if we actually learn to couple to the vacuum and make it spin in a region of space where it's not spinning, right, then we can make artificial gravitational field, we can control gravitational field, all of a sudden we can travel to the stars, we can do all kinds of things that we couldn't do before. So it could have a huge impact on our civilization. You know, the way we produce energy, the way we move around the universe. You know, we could get rid of fossil fuel for power production and for energy and so on. I mean, there's huge amount of changes that will occur on our planet if we're able to tap into this new source of energy, the vacuum structure, the basis energy that produces our universe.
Na koji način biste mogli objasniti kako bismo se mogli, recimo, kretati u jednom svemiru koji je fraktalan po naravi?
Okay, well, you know, if gravitational fields and mass and energy is produced from the spinning structure of space-time, as I describe it, then, and we figure out how to spin space-time to produce that, to reproduce that, we could create enough spin to produce wormholes. So wormholes are structures that were predicted by Einstein field equations, you know, showing that in certain region gravity may be strong enough that it produce like these vortex, these little wormholes that connects things at a distance. And as I was saying earlier, now physicists are starting to realize that maybe when particles are entangled in a laboratory, so that when you move this one moves instantaneously, no matter how far it is, even if it's on the other side of the universe, when you move this one moves. Well, if that's wormholes that are producing that, and we are able to spin space-time to open the mouth of a wormhole, we might be able to entangle two places in space and time that are billions of light years away from each other, so that you can walk in this way and come out that way, right? And you know, this is the stuff of Star Trek, like warp drives. Is it completely impossible? Absolutely not. Actually, not only does the physics say it's possible, but you know, for instance, NASA is trying to produce warp drives at this point, and you know, there is evidence that it can be generated from the theory I'm writing, from actually fairly low energy levels, that we don't need huge amount of energy to produce them. They're actually naturally occurring. We just have to get the space-time structure in a local area to behave a certain way, and then all of a sudden we can open up these tunnels through the structure of the universe and travel very long distances in a very short amount of time. So it really opens up the possibility. And you know, if you look at history, you find that some of the greatest inventions we have, you know, planes, submarines, rockets, all kinds of things, were in science fiction long before they were invented, because people have to be able to imagine these things to actually be able to produce them. And you know, I don't think it's surprising that you know, very popular TV shows like Star Trek and Star Wars and all this that talk about wormholes and warp drives and all this have been there for a long time. I think now our reality is catching up to this possibility that we had both in our imagination but as well in our physics, meaning the physics of gravity all the way back to Einstein already predicted these things could happen.
Ako je vakum znači izvor svega što postoji i vidljivog svemira, a i onog nama nevidljivog, zaključili ste da mora imati neku geometriju ili nekakvu strukturu. Kako ta geometrija i ta struktura izgleda?
Okay, so basically, when you solve these equations I wrote for this fluctuation of energy that's present at the quantum level, at the very fine level of the Planck, these fluctuation, these tiling on the surface of the black hole and on the inside of the black hole, they are tiling in a very specific geometric relationships. And these very specific geometry, you know, seem to match many ancient tradition, description, and symbols that they called sacred, that these symbols were like fundamental to the universe, that these symbols had something very profound to tell us about the universe and how it works. Well, it seemed to be that that's correct, that it turns out like these solutions for gravity that my equations come up with actually predicts that the way the Plancks organize to produce those effects is literally very typically these geometry that are found in ancient civilization in many different cultures around the world. And so that's kind of stunning. And it's very strange in some ways. You wouldn't expect that, right? Except two things. One is that if truly the universe is made out of this fundamental Planck geometry, and these wormholes that connects the dots and makes the geometry, then maybe, since we're made out of that ourselves, maybe, you know, with high level of awareness and consciousness, we could tap into that and actually, you know, you know, get like a sense of it, and maybe the shamans in these ancient civilizations kind of got that view or got that idea and drew it and came up with it. But as well, if you look at all the ancient civilizations, or many of them, there is many anomalies you find in these ancient civilizations. You find buildings that we couldn't reproduce today. You find all kinds of huge objects, in some cases in excess of 1,000-ton objects that were moved across valleys and mountain range and waterways and all kinds of things like that, that were brought to the top of mountains in some cases. And these objects are not anything we could lift and move that far or that high with our modern technology. So when you look at these ancient traditions, they don't claim they did any of this. They claim that some sun gods came from the stars and taught them everything they know, everything they knew, and that built these buildings and so on. And so maybe, and this might sound really out there, but maybe there was ancient aliens, right? Ancient extraterrestrial communities that visited the Earth, that had this understanding of gravity, that had this understanding of physics, that left information about the structure of space-time, about how space-time works and how to control gravity. And that's why you find it in these ancient civilizations, you know, all around the world, that have all these anomalies in them.
U redu, ali kako ta geometrija zapravo izgleda kada bi se opisali na neki način kroz tijela ili oblike u geometriji?
I think one of the sacred geometry that has been very much popularized in the last few years is what people call the flower of life. And it's like intersecting rings that makes this geometry. Like if you can imagine this intersecting ring thing, but in 3D instead of flat on the surface. So a 3D like spheres interacting, right? Intersecting, all packing together, right? This is the solution to gravity from my formulas. And if you actually imagine that you would triangulate, meaning that you connect the center of each spheres together, you would get all these tetrahedron, these triangular structures that all come together and makes this like very fundamental seed of tetrahedrons that makes up the structure of space-time, so that you can actually visualize how the structure of space-time network is connected across. But this is at the very, 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 very fine level. It's not anything you can see. It's not anything you can measure even with our technologies. It's too small. It's much smaller. We know it's there in quantum theory because we can measure the difference. Like we can put two plates together close enough, and then the plates get pushed because there's less vacuum energy between the plates than on the outside. But so we know it's there, but the structure is such at a fine level. The equations I wrote show that the structure is there and that the geometry is present, and it's that fundamental geometry that you find in many different cultures. You know, for instance, the 64 hexagram of the I Ching is a description of that geometry. You get the flower of life. You get so many different ways of expressing this geometry is found in various cultures all around the world.
Ako je svemir zaista fraktalan po svojoj naravi, to bi značilo da se ta njegova fraktalnost mora održavati na svim razinama postojanja, pa to znači da bismo morali uočavati i na našoj razini materijalnoj. Zanimljivo je što doista postoje primjeri u biologiji, pa čak i kod same vode, u kojoj se doista oslikava ova geometrija o kojoj ste pričali, koja ima 64 jednakostranična, zapravo četverostranične piramide.
Yeah, well, you know, that's the thing, is like if you look at water, this is a very good question, because when you look at water, you know, water molecule is tetrahedral in nature. And so, and then the water structure is from which all life emerged. meaning that all life comes out of water. So you expect, if there's this field of information that's actually creating the feedback and creating the complexity, and that is producing the biology we see around us, then you can imagine that this tetrahedral structure of water must be interacting with the tetrahedral water the structure of the Planck at a very different scale, right? So it's like the information moving through the scale, through the same geometry. And then when cell emerge, then the cell, when they divide, right, then you have 2 cells, then you have 4, then they make a tetrahedron. And then you have 8, they make a reverse one. And then they built in this 64 tetrahedron grid as well. And then you look at the DNA, and the DNA has, 64 codons. That is the code that makes the DNA structure function, and so on. So now you start to get like that. This geometry is like scaling at different levels, huge scale difference between the Planck and biology, but that the information is being transferred from one level to the other. And of course, there's some distortion as it goes, so that there is some loss of energy, so that there's entropy in the system, and things can build in complexity and then they decline, and so you have the building of a being and then eventually the decline of a being. But actually, if you could modify the water so that it stays in high level of coherency in relationship to the vacuum, you could kind of maintain maybe and extend life significantly by maintaining the structure of water. And just recently, I've been saying this for a long time. Scientists study the brain to try to understand consciousness. The brain is only 10% of what's up there. The rest is water. The scientists study biology, like study the DNA. But the DNA is packed with water molecules. If you take the water molecules away, the DNA falls apart, doesn't cohere. So so now recently, only a few months ago, I'm very glad to see this occur. We're able to measure, we're able to see that it's the water molecule that's modulating the folding of DNA, the way that DNA communicates. So it's actually the water that is producing the information that makes the DNA do its thing. Water is not just this background neutral medium that biology happens to emerge from, but actually water is the conduit of information from the vacuum fluctuation into the water structure, the hydrogen and oxygen, and into, eventually producing biological system using the minerals, relationship and the whole complexity evolving into 100 trillion cells that are like communicating impeccably every second. Billions of chemical changes are occurring in you every second for you to be sitting there. There's incredible communication links that are occurring. There's incredible non-random effects. Like you could say, almost neg-entropic effect, right? It's not going towards disorder. Biology is showing the universe going towards order, right? And so it really starts to give you an understanding, a deeper link. And I just published a paper with Dr. Val Baker and William Brown on the link between the vacuum structure and the information in the vacuum structure through the biological structure into eventually creating a conscious, self-aware system, so that we can actually explain that the consciousness is not manufactured inside the brain or inside the water even in the brain, but that the water is like an antenna oscillating with all the biological rhythm of your body, creating a link to an information field that we are linked like an antenna on a radio set that's tuned to a frequency, and we actually are receiving information and we're sending information in our actions into this field of information, and that is what consciousness is. So it's not produced in the body. So there's huge implication both for biology and our understanding of what consciousness and how consciousness actually, or self-awareness at least, emerge from biology.
Objasnite nam vašu tabelu skaliranja, znači neku tabelu razina koju ste napravili, pokušavajući vidjeti je li vaš model fraktalnog svemira točan, na koji način ste je radili i što je ona zapravo pokazala.
I started to do a graph because with the help of Dr. Rauscher, I was trying to explain, I was trying to see if it was true that if we looked at the universe and looked at the Planck scale, right? So those are huge difference in scale. If there was like a way to say, well, you know, actually everything in between falls on the same kind of pattern, meaning that basically, you see, space or matter is 99.9999999% space. So what we call the material world is mostly space. So, and what we say is not space, the material world, is actually just little electromagnetic boundaries that we're bumping against in the space. So maybe space makes matter, not matter defines space, right? So I start to think maybe you know, space divides in very specific scale relationship, right? The vacuum makes a boundary, and that's the universe, and then it makes another boundary, and you know, it's a galactic structure, or it's a quasar, and then it's a star, and then it's an atom, and then it's a Planck, right? So I made this scale, energy versus radius, and I put the universe and I put the Planck. And I noticed when I did the calculation for the universe with Dr. Rauscher that the universe obeys the condition of a black hole. That is, if I take the radius of the observable universe and I put in it the mass that we observe in the universe, it obeys the exact condition of a black hole. It, you know, it's a black hole. And then the next point over being a galactic center, we know that's a black hole. Then quasars, those are black holes. And then, you know, stars, stellar objects can be black holes. And then and then an atom fell on the same linear progression. And that's when I started thinking, yeah, maybe a proton, the nucleus of an atom, is a black hole. And then all the way to the Planck. So those are huge scale difference, right? But everything fell on this, you know, linear progression. So that everything was behaving in the same way. And I started to think maybe this is, you know, how space-time divides. And then when it divides, it produces something that we say, oh, here's something we see in space, but it's just a division in the structure of space itself. So it's our perception that defines what it is. And at different scales, it looks completely different because, you know, so for instance, if you were a proton and you experienced the world as a proton, you would have a completely different experience than if I grew you to the size of a human being. Right? If you grew to the size of a human being from a proton, you would think you changed dimensions. I mean, change worlds. But all you've done is literally change in dimension, change in size.
A što se zapravo zbiva sa idejom Big Banga ako je istina da zapravo živimo unutar crne rupe i da je svemir koji mi zapravo doživljavamo na neki način jednak svim tim crnim rupama u mikrosvemiru, pa na taj način i on predstavlja divovsku crnu rupu unutar koje mi živimo.
It gives a completely different picture of the Big Bang. You know, the Big Bang theory is not really an appropriate theory to actually, you know, describe our universe. It doesn't, it's more of a religion, I'm sorry to say. You know, you say there was nothing, and now all of a sudden there is everything, and it exploded, right? And you're not going to explain how it got there. You know, you're not going to explain how it, like, exploded. Where did the energy come from to do this? Where did the matter comes from? That's not really appropriate. And actually, there was a paper that Einstein wrote as an alternative to the Big Bang that just was lost and that just got found in 2013, in which it described the universe as the vacuum structure producing matter on the inside as much as matter was being lost by the universe on the outside in a continuous creation model. And I think that is much more of what is actually going on. And it's really interesting because I found this paper from Einstein was found just as I was writing physics that described this model of matter creation occurring at the surface of black holes, where black holes are actually spinning matter into existence, and that matter is being lost by our universe, and the two relationship producing the expansion of our universe. And so you can imagine the universe, instead of a Big Bang, that, you know, there was a proton inside the universe, and it escaped. And as it escaped, it exchanged from information going out to the information going in. When it escaped, because it changed density in the larger bubble that we're in, then it grew very rapidly to the size of our universe. So you could, this new view says that universes are continuously foaming off the surface of other universes, and that it's a continuous creation process. It's not just one bang.
U tom fraktalnom svemiru i u vašem modelu kojeg ste opisali, gdje je mjesto čovjeku? S obzirom da se radi o povratnoj sprezi u kojoj sve cijelo vrijeme nestaje, ni iz čega pa opet nastaje, svi naši atomi i sve što vidimo oko sebe, na koji način se na nas vraća i odgovornost za naše misli i za naše namjere i na koji način mi zapravo svojim djelovanjem utječemo na taj svemir?
So, you know, all of a sudden, when you have this new view of the universe and the structure of space-time, you know, because we're made out of protons and we're made out of atoms, so we're part of this network, right? All of a sudden, the consciousness we have is an exchange between, you know, the vacuum structure that's all around us and inside of us, and the external world that's feeding us information. So we absorb information, right, through our eyes, through our touch, through all of our senses. We feed the interpretation of that to the vacuum, and the vacuum then feed us more, you know, experiences, and in this continuous feedback loop. And all of a sudden we start to see that we're part of this incredible network that connects all of the points together, that connects us all together. The space between you and me is no longer empty. It's full of information that's being exchanged. And the space between all of us, the space of the human consciousness around the whole planet, like a morphogenetic field of all the experiences interacting with each other. And so now we're no longer isolated. We are having an influence on all of creation. And we're not, you know, this little puny thing that doesn't have any power in the universe. We're actually this part of this incredible will work of nature that we are interacting with. And we call it consciousness, and we don't think twice about it, but actually this is the manifestation of the dynamics of space-time learning about itself. The universe is literally, in this view, the universe is literally learning about itself through your eyes, through your hands, through your experience in the world. And because everyone is observing the universe from a different perspective, literally because they're in different vector in space, like I'm never going to be inside your eyes looking back at me, right? You're getting a set of information, I'm getting a different set of information. And so every point is feeding its own perspective to the universe, and all that synergize to the evolution of the universe itself.
Gospodine Haramein, hvala vam na vremenu koje ste odvojili za ovaj intervju i sretan put i doviđenja.
Oh, my pleasure. Thank you for having me.